So in this video we're going to be looking at the relationship between resistance, current, and voltage. So we have two multimeters. This one is currently set to register voltage, or potential difference if you want to look at physics. And this here is set up to measure current. So this is currently hooked up to a 1K resistor here, and since this is measuring voltage, we have it across the resistor. This is current, so it's going from one part of the resistor to the negative of the power supply, and the power supply is just off camera here. Now this is a variable power supply, so I can adjust the voltage coming out of it. And right now it's sitting at about a volt. And as I turn the voltage up, you will notice that the current also goes up, and it goes up proportionally. So if we go back to 1 volt here, about 1 volt here, we have about 1 milliamp. If I put it up to about 2 volts, here's about 2 volts, we've got about 2 milliamps. So it's going up proportionally. 3 volts should give us 3 milliamps. There we go, 3 milliamps. And then 4 volts should give us around 4. Whoops, overshot a bit. 4 volts gives us 4, and so on. So there is a direct proportional relationship between the amount of voltage and the amount of current as it goes through a resistor. Now, that proportionality also can go with resistance. So if we go back to 1 volt here, here we go, about 1 volt, and through a 1K resistor we have about 0.1 milliamps. Now if we move over to our another resistor here, this is a 2.2K resistor, so about twice the resistance. So we take that out of there and plug him in here. Still have 1 volts, but now we have a little less than half the current, because this is a little over twice the resistance. So there's a proportionality with the resistance as well. And that's where we come in with Ohm's law. So the voltage is going to be equal to the resistance times the current. And we can rearrange that formula around to work out anything we want. So if we use that, we can make some predictions. So if I have this 1K resistor and I put the voltage at 9 volts, we should get about 9 milliamps. So let's set that up. So let's move this guy back over here. Let's take this guy out because that turns the power off. Move this guy over here. And move this guy in here. So we're at 1 volt and we want 9. So let's move it up to 9 volts. My battery must be getting low on that. To change the batteries. So 9 volts. And we have a little over 9 milliamps. Now, resistors, this is a 1K resistor, but we can measure its resistance here in a little bit, but it's probably not exactly 1K. It's got a little gold band, so it'll be within 5% of that. So that's probably 5%, but 9 volts, 9 milliamps, 1K resistor. Now we can go to the 2.2K here, so we'll take this guy out here, turn it off, and we'll move this guy over here. Now for this, theoretically, we should have about a little over 4 milliamps. And there we are, a little over 4 milliamps. And then finally we have a 6.8K resistor. So if we do the math there, we should get about 1.3 milliamps. So let's move this over here, like so. And then plug this guy in here. And there we are, about 1.3 milliamps. So this is the essence of Ohm's law. So we can, if we know voltage and resistance, we can work out how much current. If we know current and resistance, we can work out how much voltage. And if we know voltage and current, we can work out resistance. It's all a matter of just doing a little simple math with the formula. And as we can see, it all works out wonderfully.